Please, we begin with the first conference of the day by the doctor, telecom engineer, Javier Ventura-Traveset. No, ya lo dije. Dr. Ventura-Traveset is a recognized expert in the field of the satellite navigation area, where he had the position of EGNOS Principal System Engineer, EGNOS Mission Manager, EGNOS System Manager, GNSS Senior Advisor, Executive Secretary of the ESA GNSS Science Advisory Group, and Head of the Galileo Navigation Science Office at the European Space Agency. Dr. Ventura-Traveset is also Advisor of the ESA Director of the European Space Astronomy Center, ESAC, contributing to ESAC overall strategy and acting as spokesperson of ESA in Spain. Dr. Ventura.
Thank you. Dear President of FITCE, dear Dean President of COIT, distinguished authorities, dear colleagues, very good morning, buenos dias. It is a great pleasure for me to be here and feel very honored to be invited on the occasion of this conference and also on the occasion of the 50th anniversary of COIT. Myself, I am a COIT member already for 30 years, and I feel like I share part of your history during the last 60% of your life, actually. And I am a happy member, by the way. Very proud to be here and very honored. Thank you very much for the invitation. I am going to talk about the space, which is somehow outside maybe your normal business, but there are many connections, and I was invited to talk about the space. I will talk a little bit about science, a little bit about satellite communications, and about navigation. And I think I wanted to stress from the very beginning, there are many connections between our community, myself, I am a telecommunication engineer, and the space sector. Many times we think that the space sector is really focused for aerospace engineers, but the first message I want to give you is that there is a large percentage of electrical and communication engineers in my field. I'm very active and extremely efficient, so we are in the right education for that field. Now let me talk first of all about what is my organization doing, the European Space Agency. That's where I work since already 28 years. This is an organization composed of 22 member states, for which Spain is a founder, is an important member. We have about 2,300 people, again, which is an important percentage of telecom ICT engineers. This is our budget, you can see that here. And typically there are two metrics every space agency has. The simplest metrics will be how many satellites you have developed and working well, and how many launches you have performed. And here we have our metric, 80 satellites developed, designed, and tested. These are not normal satellites. Most of our satellites are very innovative, as you can imagine. You can imagine the Rosetta mission, or for example, the Planck mission, very, very innovative, even in telecom, as I will explain. And 230 launchers starts to be a very high number, and which shows really we are a consolidated agency. We are the second agency in terms of budget in the world, and in many fields we are the first agency. For example, we have the single most important Earth observation program, for example. This is the last launch of Ariane 5. I mentioned that because it was launching 2 telecom satellites. And actually, a first message again, important is 50% of all telecommunication satellites, commercial ones, are launched with Ariane, either Ariane 5 or either Soyuz from European spaceport in French Guiana. This was, by the way, the 80th consecutive successful launch of Ariane 5. And this is a nice number. Actually, if you think about all the launchers, not a single one in its class has ever achieved 80 consecutive successful launches. And this gives a lot of reliability, and that's why most of the operators in telecommunications decide to use Ariane 5, okay? We are working, as you probably know, also in the next generation, which is Ariane 6. This is our mission, to promote cooperation between European states for 3 areas that you can see those here: space research, science, technology, innovation, and space applications. These are the 3 topics where ESA should focus. Science is a mandatory activity, and I will give you some ideas of what do we do. Technology is a mandatory activity, and space applications, every country decides how much money is willing to put, okay? And essentially this means Earth observation, telecommunications, and satellite navigation, and also the downstream. I will talk about that. You can see here the list of activities we take care, and if you think in all the space agencies in the world, we are probably the only one which is addressing every single topic. Space science, human spaceflight, exploration, launchers, technology, satellite navigation, Earth observation, and telecommunications. It's very complete. And you can see in red, I put it in red, the application areas. This is where the upstream is not really the most important, where the real importance is in the downstream, for example, in your fields. I will talk about a little bit of that. I have like 23 minutes maybe left, so I will have to go fast. As happens usually, you want to talk about many things and you have little time, but I try to do my best. I couldn't escape the temptation to talk about science, even though this is maybe not the core topic. I am one of those, being an engineer with a very scientific background as well, convinced that all the breakthroughs come through science. Actually, you share with me, without any doubt, that without Mr. Maxwell, no one of us will be here. And this is clear. He was not an engineer, he was a scientist. And probably when he was writing the Maxwell equations, everybody thought, what the hell is that? And I think today we are not hesitating on the helpfulness of that. So space science is important, and we are really in breakthroughs now. And let me give you some examples of what ESA is doing. Another reason for space science is that engineers and scientists work continuously. This connection is fantastic in innovation, really believe me that. I will even invite you to have scientists in your organizations to ask you for crazy things, because engineers get motivated when you ask for a crazy thing, and then they have a challenge. And this is what happened in science in ESA. Let me put some examples. Rosetta and Philae. What a crazy mission. Think about it. We are going to go to escort a comet, which we did it, more than 7 billion kilometers around the solar system, landing in a comet which we didn't know at all how it was, analyzing the comet for 2 years, and finally landing even in the comet. All that was done as a unique mission, probably one of the highest achievements of mankind, I would say. You have seen an image of this comet. This is called 67P, Churyumov-Gerasimenko. We should be proud in Europe. This is European technology. Again, plenty of us, plenty of telecom engineers and electrical engineers, plus other disciplines. And you have here, for example, some achievements in numbers. I will not go into details, but think about it. 7.9 billion kilometers, 12 years mission. First time we are in a comet in orbit. We accompany the comet for 2 years. We land in the comet. We are navigating beyond the belt asteroid with solar panels never achieved before, and many other things. 218 gigabytes of data of this pristine material. Actually, the comet is material from 4 billion years ago. So the scientists ask the impossible. The engineers make it possible, okay? You have an example, by the way, I have a short video here. The ending of this mission, which we call the grand finale, happened on the 30th of September 1 year ago. And this was when we decided the mission was too far away to keep communicating and having solar energy, and then we decided to land it into the comet, to finish in this way, and to maximize the science. And you have that here, some images of the comet and an animation of what has been this landing. Think about it, the gravity is very low, it's 10 to minus 5 gravity on Earth, so we are landing about 80, 90 centimeters per second in the last moment. You can imagine the speed. A second example of fantastic technology is Planck. This mission is acquiring the cosmic microwave background. And again, without engineers like us, it will be impossible. Let me tell you some requirements. You need to put something at 1.5 million kilometers from the Earth in a Lagrangian point. You need to cool the satellite close to the zero absolute, which is 0.1 above zero. And then this has to work for almost 3 years. And the idea is to be able to acquire the cosmic microwave background, which, by the way, was discovered also by telecom engineers somehow, by Bell Labs, checking some antennas and finding some noise, which in the end was really the cosmic microwave background. That's what we acquired. These are anisotropies of the universe 13.8 billion years ago. Again, a challenge from scientists, which engineers, and the technology we have developed here is quite unique. By the way, in terms of science, one of the things that comes out of the analysis of this cosmological data is that everything we know is less than 5%. 95%, as you are familiar with that, is either dark matter or either dark energy. We simply don't know what it is. And you know very well, when you study those things and you suddenly discover what it is, the numbers of discovery multiply. That's the importance of science. And this is one of the key topics where ESA is focusing now with several missions in this direction. Let me talk also on gravitational wave. That's also a fantastic moment of history. No? We are working with electromagnetic waves who tell us that maybe we will have nothing to do, maybe we have something to do in the future with those, isn't it? Today it looks like impossible, we have nothing to do. Gravitational waves, as you know, were actually 1 year ago, not exactly 2 years ago, were confirmed. It was the 14th of September, so it's exactly 2 years ago. The first confirmation with LIGO, as you know, the collision of two black holes. And this is a fantastic discovery. It's an opening of the astronomy. We are really going beyond our normal radioelectric, electromagnetic observations. This is really fantastic, and this has been detected 3 times already and growing the number, and this is already providing a tremendous knowledge. Let me tell you that because we are working in ESA in parallel, by chance. During the same moment the gravitational waves were detected, we launched what is called LISA Pathfinder, which is a technology mission, very complicated, believe me, very complicated, to be able to demonstrate that we have the technology to detect gravitational waves from space. Gravitational waves from space are much more interesting than those that you can detect from ground, because you can have what is called low-frequency gravitational wave. There are many more phenomena in the universe expressed in that frequency. So we have the technology, and we are preparing a mission called LISA, which will be launched in the 2030s, which will really be the ability to detect gravitational waves from space, very complementary. And whatever you talk with any astronomer, he says the numbers of discovery of that will be equivalent, or maybe more, to what we did with electromagnetic field. So be prepared to a revolution there. The third topic on science, which I think is hot, is the search for life. Also there, we are in a fantastic moment. It's one of those discoveries, if it happens, that we discover life beyond Earth, which has what we call in science civilization impact. Civilization impact means it's not just giving you knowledge, it is changing the way you think about everything, isn't it? If you find life in Mars, for example, very close to the Earth, really very close, this means this is something like, looks like it's impossible to avoid, and it's a natural trend of the universe, where you find life a few years light from here. So ExoMars is looking for that question, in the question of methane. We have another mission in 2020, penetrating in the terrain. I don't have time to explain, but these are missions related to what we call astrobiology. Other hints of life is the possibility of finding life in the icy moons of Saturn, like Enceladus, or in the icy moons of Jupiter. We are really there. We have seen, for example, in Enceladus, we have all the ingredients for life, like energy, like water, like complex organic molecules. The three together is like the combination. If we really find life there, these conditions happen in Earth without even sun energy, this will be a fantastic discovery. And again, we are very close. And then exoplanets. This is also amazing. More than 3,500 exoplanets discovered. You see, we are really in a change of paradigm in astronomy and science. And with the launch of James Webb Space Telescope, again, a glory of technology, plenty of telecom engineers working there as well. We will be able, for example, to analyze the spectrum of the atmospheres of those exoplanets. If we find signatures, like the one of the Earth, actually, in the end, what you will say is that there is a biological activity. You can imagine this discovery, it is in a reach, let's say 10, 15 years, probably we can have a bingo of this caliber, okay? So I just wanted to give you a flavor that science and technology go together, and we are a very important community. Let me dedicate the next 15 minutes, if I have those, to satellite telecommunication and navigation, which is more related to our field, okay? This is the application field. There is also Earth observation, which I will not have time, but if you have any question, I am very pleased to give you information. Telecom in space is very important, as you all know. Approximately 8% of all telecom are satellite telecommunications oriented. It is the largest space business, 100 billion. Maybe for terrestrial telecom is not such a tremendous amount. It still is an important amount. It's about 40% of all space budget is space telecommunications. And look at this figure. From all operational satellites in the world, 50% are telecommunication satellites. So if anyone says that the telecommunication engineer has nothing to do with space, he's totally wrong. Okay? Look at these figures. 1,459 satellites are operational. This was data from 31st of December. And look at that, 50%, by the way, precisely 50%, either commercial telecom, government telecom, or either non-profit telecom are 50%. About 700 satellites of the 1,400 are related to telecommunications, out of which 500 are in the geo orbit today. Okay? Typically for the Europeans, we are in that area, between plus minus 45 degrees, and 500 satellites today operational in the geo orbit. And you can see the mega constellations we'll talk in a minute going on. The case of Europe, you are, I think, most of you coming from Europe, and we should sometimes be proud of our Europe. And in this case of space telecom, we really can be. Look at these numbers, 3 metrics. 1 out of 3 telecommunication satellites in the world are performed by European industry. By the way, with an important contribution with the Spanish telecommunication industry as well. Several of them represented here. So we are a very important community. 1 out of 2 telecommunication satellites in the world, I already mentioned that, is launched with Europe, with Ariane 5 or Soyuz from Europe. And 3 out of the 10 most important telecom operators are European. Number 1 is CES, and then we have Eutelsat in the top 5, no doubt, and Hispasat in the top 10, Spanish one. So you can imagine how important we are in this community, and we have been growing, not decreasing, while in other topics, our importance maybe has decreased, in satellite telecommunication has been growing. No? ESA is supporting that industry. In which way? We are doing what is called PPP, private-public partnerships, providing technology, innovation, and allowing the operators to risk without having to risk too much with this government support and the engineers of ESA and the European industry. And you have here the example of the last telecommunication satellite launched by ESA. It was a partnership with Hispasat. This is called 36W1. In the ESA, we call it a small GEO. This is a platform developed by OHB in Germany, which is a telecommunication satellite quite innovative. For instance, with generation on board processing, beamforming, dynamic beamforming, an active antenna with a tremendous involvement of the Spanish industry. This satellite is working pretty well, is an example. Now, like in your business, satellite communication is also in changing paradigm, like anything else on planet Earth, isn't it? We are in a kind of revolution in every field, and of course, satellite communication cannot escape from that. And let me mention the 3 obvious paradigms that you share, I think, in your communities. We are not connecting people anymore. We are connecting people and connecting everything. That's one change in the mentality. We are not anymore fixed antennas to one house, for example. We are now mobile. We have to communicate anyone, whatever his speed, wherever he is mobile or whatever. And secondly, we are changing from a broadcasting in one direction to a streaming and certainly broadband internet. This is the change. This is the paradigm. This actually brings me to something related here, which I would like to invite you to participate. ESA is active now in what is called a satellite for 5G. The idea here is to understand and to promote and to demonstrate the added value of satellite navigation into the context of 5G. So we have decided to join effort with 16 industries to see how satellite may fulfill and complement the 5G initiatives. This means demo trials, this means standardization work, and this means discussion with PTTs, for example, or experts in 5G. I think we are in the right moment before 5G is really there, and I really would like to transmit the message. This is a priority for the European Space Agency. I will not enter into detail, but this tries to explain the many situations where satellites are favorable to complement terrestrial 5G. This is the way to think, really. It's not a competitor, it's really a complement, allowing to communicate everything and everywhere, okay? These are the 16 companies which are working today in this initiative, Satellite for 5G. And you can see we have the main operators, Hispasat, Inmarsat, Intelsat, Eutelsat, CES, the 2 main manufacturers of Europe, Airbus, Space and Defense, Thales, Alenia, several companies. You see here OneWeb, for example. And let me finish this telecommunication part with OneWeb. That's one of the amazing revolutions ongoing. Let me see. So this is the OneWeb constellation, which you are familiar with. That's a tremendous revolution. It is a mega constellation. We are talking about 700 satellites. These are going to be developed in Europe, in part with Airbus. The line manufacturer is already open in Toulouse. They are going to be launched in part by Europe, so Soyuz. There are already agreements. The frequency allocations are finished. The line production is starting, and I understand by next year they will launch the first satellites. The idea is to provide, as you know well, broadband communication internet everywhere in the world in high speed, from 100 megabytes to even gigabytes. And this is really a revolution in everything we think in space. It's not a single satellite, it's several hundreds, and they even think making satellites in only 3 days, like a car manufacturing, which is a totally change of paradigm in the way we work. So we are really there, and this is the moment where our collective has a major say in. The last 7 minutes, if I have those, and checking my time, I would like to dedicate to the other big chapter where I think there is a tremendous connection with your communities, and this is where I worked for the last 20 years, is satellite navigation. What a tremendous revolution we are also going through, and Europe is now a key player with Galileo. Let me give you some data, for example, that not many people know, how many navigation receivers we have in planet Earth. And today it is estimated about 6 billion. 6 billion, no? 6,000 millones, just to be sure. Billion in Spanish and English is not the same. So 6 billion, it is a fantastic, you can imagine. The idea, today the projections is 8 billion by 2020, and I think they are conservative. They are not taking into account the Internet of Things, most likely. And actually, this brings us to something like by 2023, in the case of Europe, we will have in average, every citizen, including babies and old people, an average of 2 receivers with GNSS. GNSS is the acronym we use for satellite navigation in general, Global Navigation Satellite Services. 2 sets per person, 2.5 in the States, 2.3 in Asia, China, Russia, even in Africa, 0.8, you can imagine, and 1 in South America. This is 2023. It is not very far away. It's only 5 years from now, essentially. So this is going to happen. As you know, we are integrated everywhere, especially in smartphones. 80% of all receivers on GNSS are integrated in mobile phones. And you know very well, we are part of the same business, but also in tablets, in digital cameras, clocks, everything that is wearable. And this is simply normal. The chips are very small. These are all chips of about 1 centimeter square, multi-constellation, which means GPS, Galileo, the Chinese system, which is called Beidou, and the Russian system, all are integrated here, allowing to have 100 satellites. This is really a revolution ongoing, very, very, very fantastic. Applications everywhere. You cannot imagine. I think there are identified more than 40,000 applications using satellite navigation. Of course, satellite with telecom is the winner, as you know well. 40,000, and this is just growing. When GPS was invented for military use, they were thinking about 30,000 users, and they were thinking in probably planes and missiles. And I think it's a very good news for the civilization. We now have 6 billion, and really for many other things which are much more interesting. And you can go any field of activity, because it's simply normal to know where you are and to know what time is it. It is intrinsic of the human being. And here is what we do with satellite navigation. In terms of economy, look at these figures. They was computed by the Commission that if you stop satellite navigation in Europe tomorrow, like if you stop telecom, let's stop satellite navigation, the impact will be on the order of 6 to 7% of the global economy. You can imagine what we are talking about. It's about 800 billion euros. Well, only that information provoked somehow immediately the decision to have independence and to develop Galileo. These are the 4 constellations in the world. As you know, GPS, Galileo, GLONASS, operational. Galileo, which is providing initial services since December last year, and Beidou, which is also providing services in China. So we have 4 constellations. All, it is foreseen to be fully operational by the 2020, or around that year, which is also tomorrow. So in the moment 5G is there, the 4 constellations are operational. And I would like now to dedicate some information on Galileo. Galileo is our system. We are very proud of what we are achieving. It cost a moment, but now we are already having 18 satellites in orbit, 14 of what we call family FOC, and 4 of family IOB. So they are already in orbit. We are going to launch 4 more this year, so we'll have 22. And 4 more next year, we'll have 26, which is already above the nominal number of operational satellites, which is 24. But we still will launch more. We have already ordered 8 to 10 more already this year. We have an official operator, and very importantly, it is now officially providing services. This is a Galileo satellite. This could not be built at all without electrical and communication engineers. Here I can bet that the large majority of the people working in Galileo has a background in electrical and communication engineers. Without us, this will not exist. Let's be a little bit proud of our community. And this is simply normal. It's really signals, it's really signal processing, it's really managing communication, transmission, and everything that we know is fitting very well here. Okay, I will not enter into the details, simply to mention that two of the key technologies, one of the key technologies is the clock technology. Actually, the satellites on board need to have very precise clocks. By the way, without Einstein, coming back to the science, you know very well, without Einstein, GPS and Galileo will not work because we'll have a frequency variation that we will not understand, which is due to the general relativity. So again, the connection with science and technology. So here we have clocks with a precision of 1 second in 3 million years. So it's 1 nanosecond per day. And you can imagine the tremendous opportunities this opens for telecom. Time is one of the key elements of Galileo in addition to positioning. We are launching in 2 launchers, Soyuz and Galileo. Everything is diversifying Galileo. We have 2 control centers, 2 manufacturers, 2 clock technologies, 2 launchers. We have to avoid what we call in our technology single points of failure. It's so strategic for Europe. No? This is the year 2016 has been a fantastic year for Galileo. We call it the year of Galileo. And let me tell you a few things that happened on that year. First thing is we launched for the first time with Ariane 5 for Galileo in a single shot, this work. Never in history, never one launch for navigation satellites in a single launch. This was the first time. And this means we can complete the constellation very fast. The next launch is December this year, and the next launch is next year. So you see, in 3 launches, you have 12 more satellites. You have here a little bit the last stage, the 4 Galileo there, and I will not enter in details. This is fantastic launch with a steerable stage, which is igniting several times and putting that in a circular orbit about 23,000 kilometers. It's about 300 kilometers below. And then the last 300, it is the satellite with the propellant, which is racing. Second extraordinary news of the year 2016 is the initial services. Probably the most important day of the history of Galileo. Everybody was thinking, okay, this Galileo, there are delays, there are always problems, there are wherever. Okay, whenever the service is there, I think people will forget, and now we will use it. And today, can be used. So since 15th of December, Galileo has declared initial services. You have 2 documents, which are here mentioned, which explains the level of performance and also the specifications to build receivers. And let me tell you with some proud as a Spanish telecommunication engineer that the first European Galileo ready was developed by a Spanish company. And I allowed to make some publicity. BQ Aquarius, which I believe the owners and the engineers are coming also from the Telecommunication Engineering School of Madrid. So you see we are helpful, and this was the first Galileo ready before even Galileo was declared operational. Now, what is the downstream market? We could talk about 20 hours on that, and I will not do, don't worry. But obviously, these are the emerging markets, location-based services. As I mentioned, 80% of our applications are integrated in mobiles. Road and car industry, what a revolution is going there, you know. Advanced driver assistance, automatic driver assistance services, for example, we are working on that, really achieving accuracies of centimeters. You know, for instance, there is a regulation of the European Union called eCall that from April 2018, so it's tomorrow, it's in April next year, every car in Europe, which is manufactured in Europe, needs to have an emergency service calling the 112 and indicating the position in case of an accident. So automatically means every single car in Europe, it will take a while, maybe 3-4 years, will have integrated GNSS. So you can imagine the revolution that is happening. Internet of Things. We are a key player there. Even if 5G allows to position very clearly, we can really be very complementary, and I will talk about it in a minute. Drones and aviation, we are already landing planes in Europe with GNSS, with GPS and EGNOS. We are landing in many airports already. It's a fantastic technology. And drones is a very natural technology, and we are working on that. And smart cities. Again, I think this is a little bit the subject of you. The only thing I am telling you, don't forget satellite navigation, don't forget space communications in that business. This brings me to this slide, which is almost the last one, which is about 5G. Again, in ESA, we are aware that we cannot live without the other communities. So we have launched an initiative similar to the one you saw on satellite communications, which is called GNSS and 5G. So we are convinced GNSS is a key player here, satellite navigation, and we have decided to launch several studies to identify the way we can complement you. And secondly, also very importantly, to identify things that we can do to our Galileo constellation, modifications, which may allow to better fit into the 5G context, okay? So it's a symbiotic relation. And you have here a list of bullets of examples. We can provide, for instance, cellular network synchronization. We are providing nanoseconds, stable. We are even able to provide reliability to this time. We can provide accuracies of centimeters. This is really reachable in a few years. In a normal way with an open smartphone, this is really reachable. And also, again, with reliability. Data dissemination of 5G, the connection of internet, and GNSS is a winner. Without assistance GPS or assisted Galileo, you will not have the position in 1 second as you get it, obviously, as you know. With high-speed 5G, the possibilities are enormous. So open your imagination, because this is really like that. Reliability, security, redundant technologies. We can have anti-spoofing technology thanks to you. Low power consumption devices. You know, with GNSS, you can determine the position in 1 second. And maybe you don't need it anymore for a while, so it's very low power consumption. This can be exploited in the Internet of Things, for example, okay? So I have 1 minute. It's 1 minute. I see that you allow me that. And I couldn't resist to come back to science. And it's only 1 minute because I think it's relevant to tell you that tomorrow is a very historical day. It will be the grand finale of Cassini mission. So tomorrow when you see that in television, remember myself. So the September 15th, we finished this fantastic mission, Cassini-Huygens, which has been a mission launched 20 years ago. One of those fantastic missions going around the solar system to reach that, which has been essentially 10 years, more than 10 years, since 2004 in orbit, Saturn, so 13 years, and where ESA, the European Space Agency, all of us, Europe, had a major contribution, which is Huygens. Maybe you are familiar. This was the probe which landed in Titan in 2005, and I finished with that video, which is an animation, but the background is true. These are the images. This was the landing of Huygens in Titan. This happens on the 14th of January 2005. And this is the single object developed by human beings which more far away has landed in a celestial body. We have the Guinness record. But again, technology there is amazing. Let me tell you one secret. This mission was saved by telecommunication engineers. This is almost a secret, but here I know I am not even recorded. And no, what is true, I can tell you honestly, it is there was a problem actually discovered when the mission was active, that there was a problem with the Doppler. The Huygens probe and the Cassini had a speed of Doppler such that the bandwidth, as you know very well, was going out of the baseline bandwidth. And telecom engineers there, I remember one colleague in ESA saying, we are going to have a problem, we are not going to track. If you don't have data, you have nothing, obviously, because this data was going to Cassini. And the guy was insisting there is a problem with Doppler, and everybody said, go to hell, we don't want to have problems. Finally, he wrote a serious paper, and this was so convincing that we changed the trajectories, so to fit in the bandwidth of Cassini, and this worked very well. So thanks to our community. So thank you very much.